think I just recorded a whole entire video without actually recording the video. Okay, we'll do this for the third time. So for my question, suppose we know that the galoots on planet Z have an average weight of 6.98 pounds and that the standard deviation is 3.72. A researcher plans to randomly sample just one galoot, and we want to estimate the probability that the galoot sampled weighs more than 11 pounds. So in order to do this, we're going to find the Z-score for 11 pounds. And what we will do to do that is we'll take the 11 pounds minus the mean weight, which is 6.98, and divide that by the standard deviation of 3.72. That gives us a Z-score of 1.08. Now, because we want to find out how many galoots sampled would weigh more than 11 pounds, we want to find the area underneath this Z-score. So we want to find the probability that Z equals less than 1.08. And we'll go to the normal table in just a second, but just a quick note, if we wanted to find how many weigh less than 11 pounds, we would find the probability that Z is greater than 1.08. So I hope that makes sense. So we're going to go over to the normal table real quick. Let me get out of this. And we will find 1.08, which is about 0.86, so about 86% of the data will fall underneath that Z-score. And then we're going to subtract that from 1 to find the probability that the galoot weighs more than 11 pounds. So 1 minus 0.86 is 0.14, or 14%. Now we're going to go through the same process for the next problem, which is over kangaroos. We're saying that they have an average weight of 13.06 pounds and that their standard deviation is 3.98. We want to find the probability that the kangaroo sampled will weigh more than 21 pounds. So we want to find the Z-score for 21 pounds. So we'll take 21 pounds minus the mean weight, which is 13.06, and divide that total by 3.98, which is the standard deviation. This is going to give us a Z-score of 1.99. So again, because we want to find the probability of them weighing more than 21 pounds, we'll find the probability that Z is less than 1.99, which is the area underneath that Z-score. And what we find by looking at the normal table is that is roughly 0.97, or 97% of the data should fall underneath there. So we're going to subtract 0.97 from 1 to find the probability that the kangaroo will weigh more than 21 pounds. So 1 minus 0.97 is equal to 0.03, which gives us a 3% probability. I shouldn't put chance on these, but a 3% probability that a kangaroo will weigh more than 21 pounds. So for the last part, it says, in order to estimate these probabilities, what assumption did you make about the galoots and the kangaroo weights? Was the assumption reasonable? And to answer this part, you'll want to watch the videos. So I did watch the videos, and we'll go over those in just a second. In order to estimate these probabilities, we would assume that the distribution of both of the galoots and kangaroos is relatively normal, and that these mean weights and SDs are accurate for both species. So the mean weight and the standard deviations we were given here were accurate. Based off of the videos for question 15 and 16, again, I'll go over those in just a second, the assumption of normal distribution was relatively reasonable, maybe a little bit less so for the kangaroos, but still relatively reasonable. However, the average weight did not quite fit with what other students found. Our probability was much closer with the kangaroos, which we'll see, but with the galoots, the average given for this problem seems to be much lower. So 6.98 seems to be much lower than what the actual weight of a galoot is, causing the probability that we found to be much lower than it should be. So we'll go to these videos real quick. We'll go over the kangaroos first because that's the one that was closer to normal. As we can see, this was really a relatively normal sample. And we found that there was a 3% probability that a kangaroo would weigh more than 21 pounds. And as we can see from this, that is relatively accurate. Some of the other ones had maybe one here, one here. So it is likely that our average weight given in the problem that I did was pretty accurate for the kangaroos, along with a standard deviation. Now, if we go up here to this student's sample draws, we'll see that again, relatively normal, maybe this one a little bit less so, but the average weights for his sample polls were anywhere between 12 and 13.5. So that is almost twice what the mean weight was given as in our problem. So as we can see, even though we found a 14% chance that a galoot would weigh more than 11 pounds, that is completely inaccurate because the galoots seem to have an average weight that's more than even that 11 pounds. So we would expect the probability to be much higher, as we can see a much greater amount of the sample than 14% falls above 11 pounds. I hope that makes sense. If anybody has any questions, let me know. I would be happy to answer them the best I can.